Hello and welcome to Chapter 2 Modulation in FM Frequency Modulation. Okay, in this topic, we are going to learn about angle modulation, which is there are two different parts: frequency modulation FM and phase modulation PM, where FM is the process of varying the instantaneous frequency of carrier signal accordingly with instantaneous amplitude of information signal, while PM is the process of varying the instantaneous phase of carrier signal accordingly with instantaneous amplitude of information signal. So the differences is where it is comparing with frequency and phase of the signal. Okay. So frequency modulation, FM, and phase modulation are two types of angle modulation, where FM is most commonly used analog modulation techniques, but PM or phase modulation is rarely used in analog system, but its variation used often in digital communication. So in our syllabus, you are not required to learn about phase modulation. We are only reaching up to FM, uh, frequency modulation. Okay. So this is how a diagram for FM should look like, where the green signal over here, the green sine wave, is your carrier signal, while the red one is your modulating signal. So the changes in the output is where the frequency of the signal is narrower or wider based on the amplitude of modulating signal over here. As you can see, the lower the amplitude of modulating signal, the wider the output frequency of the signal. Okay, so as you can see, this is the higher part of the amplitude for the modulating signal. The signal of the output is narrower compared to the one with the lower modulating signal values. Okay, the lower amplitude gives wider frequency for output, while the higher value for modulating signal gives narrower frequency for the output. The frequency of the carrier wave is changed according to the information signal, and the waveform that are more spaced apart represented by the values of the sine wave. Waveforms that are close together represent the peaks of the sine wave. Okay. The frequency of the carrier wave is changed according to the information signal, and the waveforms that are more spaced apart represent the value of the sine wave. Waveforms that are close together represent the peaks. I think this is the same explanation. Yeah, this is the same explanation. So yeah, what I have mentioned just now with this should be simple enough if you want to compare by reading the text below. Okay, let us go through with frequency deviation or delta F. Relative displacement of the carrier frequency compared to the original frequency in unit hertz. Okay, so in FM, the carrier frequency change in proportion with the modulating signal amplitude. We have gone through this text before. The amount of change in carrier frequency is called peak frequency deviation, and sometimes it is expressed as maximum carrier swing, which equal to 2 delta F. The deviation is proportional to the amplitude of the modulating signal. Okay, and this is the frequency deviation delta F. The peak frequency deviation can be calculated as delta F equal to Kf multiplied by Vm in Hertz value. Okay, Kf is deviation sensitivity, and Vm voltage modulating is peak modulating signal voltage. So we can see that delta F directly proportional to the modulating signal's amplitude. The deviation sensitivity is a constant that shows the sensitivity of frequency modulator and represented the input and output transfers of the modulator relationship between input voltage Vm and the resulting frequency shift delta W, delta omega. So in here, as you can see, Kf can either be delta omega over delta voltage M, or Kf is equal to delta F over delta Vm. In short, it shows how well the modulator works.